Hi, welcome to my this video, and today I will be trying to solve the another left two types of power rule integration. So let's try to solve that. So the second last power rule type of integration the is the reciprocal of a number integration. So for example, if I take that 1 by x dx, then if you look into this question, we'll get that we are not able to use the power rule. Okay, because power rule states uh, that for a base which has a power of like n, for a base x which has a power of n, then the power rule of the integration is n plus 1 divided by the same n plus 1 plus c, which is the constant. So for this question, that 1 by x dx, we will we are not able to use power integration. So the answer of this the answer of this integral is natural log of x, natural log of absolute x plus c. Why I am telling you? Because when we the derivative, when we try to derive the value of, you might have seen that when we try to derive the value, to derive the derivative of the value natural log of absolute x, we will get we get 1 by x. So by making the correct use of antiderivatives, the answer should be that 1 by x dx integral sign equals to natural log of x plus c. So this is one of the most important types of power rule integration, because most of them uses the power rule, and the answer gets wrong. So if we use the power rule, why it is not allowed, or it will be said wrong if we use this power rule in this type of integration, is because according to the power rule, 1 by x, the power becomes x minus 1 plus 1 divided by sorry minus 1 plus 1. So now in the power rule, we have stated that the exponential should not be minus 1, because if it is minus 1, then the answer must be wrong. Okay, so this is the main reason that why we are not able to use the power rule in this type of integration. So now let's move on to the last type of integration. So now the next and last type of power rule integration is the definite integral using the power rule. So for which, if I take the integral of 1 and 4, where we have to do the integration of x square dx. So in this question we have to simply use the power rule, but in a break manner. So for this, we'll try to integrate this part according to the power rule. So now, if we integrate this, means x squared dx, we'll get that x squared plus 1 divided by 2 plus 1 plus c. So here we get that x cube divided by cube plus c. So So when we try to integrate the x squared dx by using the normal power rule, we get that x cube divided by 3 plus c. So now, if you want to do the definite integral, we would do that x cube divided by 3 to the power 4 divided by 1. So now if I substitute these terms of the x, like x equals to 4, x equal to 4 and x equals to 1, I would get that I would get that 4 cube divided by 3 minus 1 cube divided by 3, as here the power is 1, and so that's why I've written only 3, but you can also write 1 for better showing. So we would get that 4 cubed equals to 64. So here becomes 64 divided by 3 minus 1, as 1 cube is 1 divided by 3. So now if we just subtract, we would get 63 by 3, which is directly 21. So here the area of the curve, because mostly in this type of definite integral power rule integration, our main goal is to find the area under the curve, okay, which is the y equal to x square from from x equal to 1 to x equal to 4 units. So the area under the curve, the area under the curve, the area under the curve, which is y equal to x square from x equal to 1 unit to x equal to 4 units, is simply 21 square. 21 s cube means square units. So whenever we are trying to solve this type of integration, like the definite power rule integration, our main goal is to first we have to separate the terms. For doing a better way, in a better way, we have to just separate the terms, which is x square dx. So now we will try to x square of x square or many other types of integration like x cube, x to the power 4, hence goes on. So after integrating any number, we will just use the power rule. For example, if I take another example, which is integration of 4 to the 1 x cube dx. We'll just try to simplify this using the power rule, which will be just x to the power 4 divided by 4 plus c, and then after after this we will try to substitute the terms x, wait, yeah, x to the power 4 divided by 4 to the power of the given integral, which is 4 to 1. So now, in the same we will just try to solve x to the power 4, sorry, 4 to the power 4 to the power 4, as we have already substituted terms from x equals to 1 and to x equals to 4. So now as we have substituted the terms x equals to 1 to x equals to 4, we'll just use the power rule, and then as we have got here 4 to the power 1 minus 1 divided by 1 to the power 4 divided by 4 to the power 1. So we'll simply get 4 to the power 4 is 256 divided by 4 minus 1 divided by 4. So we will get here 255 divided by 4. So till y equal to x, y equal to x cube terms, y equal to x cube from x equal to 1 unit to x equal to 4 unit, the area of the curve between the tangent lines. In the first video, I have already shown you that y integration is used for the, so the area that the curve is 255 by 4